Hydrogenation of aldehydes and ketones is essentially the reverse reaction of oxidation of alcohols. So if you remember, in oxidation of alcohols, we began with an alcohol that we mildly oxidized with potassium dichromate to turn either into an aldehyde or a ketone, depending if the alcohol was primary or secondary. So let's take some examples. If I start with an aldehyde and I add hydrogen to it, hydrogen is going to break this double bond, and what's going to happen? We're going to attach the hydrogen atoms back into the molecule. So we're going to get same amount of carbon, 1, 2, 1, 2, but the double bond is broken and we get OH. Therefore, an aldehyde that is hydrogenized is going to turn into a primary alcohol. And it doesn't matter where the location of the functional group is, because it's always going to be primary if it's an aldehyde. Let's take this example. I have hexanol, 6 carbon molecule with a hydroxy group. I add the hydrogen to it, and it's going to break the double bond. I add OH, 1, 2, 3, 4, 5, 6, and we have 1 hexanol as a result of the end product. So again, aldehydes, when we add hydrogen to it, they turn into primary alcohols. Now, what happens if we have another molecule such as this one? What do we call this molecule? It's a ketone, 7 carbons long, and here we have at number 4, we have the group. So this is 4-heptanone. So whenever we whenever we add hydrogen to a ketone, we're going to turn it into what type of alcohol? A secondary alcohol. 1, 2, 3, 4, 5, 6, 7. And wherever we had the double bond O at number 4, we add the OH group. And the name of this molecule is 1, 2, 3, 4, 4-heptanol. As I said, it's a reverse reaction of oxidation of alcohols. Aldehydes turn into primary alcohols, and ketones turn into secondary alcohols.